In order to find the practical domain and practical range of a function, you're going to need to find the vertex and the horizontal intercepts. Let me show you those and show you how to find the domain and range. Consider this function here we talked about last time, or last example, where a ball is launched from a house and the height can be modeled using this quadratic function. Here's the graph. We found prior that this is the vertex of the function representing the maximum height the ball reaches after that many seconds. So the idea of practical domain is, what are the possible inputs for the values of the input variable? What are the possible replacement values of t in this sense? Well, t is the time in seconds after the ball has been launched. We know after that many seconds it has a max height, but the question is, when does it reach the ground? When does the ball reach the ground, and after how many seconds? And we can stop our input values or t values there since the ball's hit the ground. So remember, to find this is really a horizontal intercept, and it's the positive horizontal intercept. So the idea we used prior was to use the intersect feature, where you place this into y1 and 0 for an output. You want a 0 height. And so we'll plug this into y1, that into y2, and find out where they intersect. Let's do that. So I have this in y1, my function here. Let's plug in 0 into there, and let's calculate now, or look at the graph and calculate the positive horizontal intercept. So we do that by second trace, or calc, and down to intersect. So here we want to intersect and move our cursor to where we think it's close to that positive horizontal intercept. Let's do there. That looks pretty good. So I'll hit enter for first curve, second curve. The cursor is pretty close to that intersection, so that looks good. I'll hit enter, and then I'll hit enter for start calculating. And so there is the positive horizontal intercept. I'm going to round to 2 decimal places. So 9.54 comma 0. In other words, after that many seconds, the ball has a height of 0. It hit the ground. So we know the ball's in flight for that many seconds. And the practical domain asks us, what are possible t values or seconds that the ball's in the ground? Hopefully you're or in the air until it hits the ground. And hopefully you're thinking, well, the t values then range from 0 to 9.54 seconds. So we'll say all real numbers from 0 to 9.54. So that is the practical domain. Practical range is, what are the possible heights of the ball? That makes sense in context. And so the idea here, what are the possible h of t values on our graph? The ball has a max height here of 376.56, so it can't be higher. So a range value can't be at 400. Remember, this is the maximum height. A range value can't be negative. The ball doesn't hit the ground and start driving itself below ground. So the idea here is a range is really from this value to 0, or all real numbers from 0 to this highest value. All right, so be aware that to find the domain and range of a quadratic function in terms of a practical domain and practical range, you need the vertex and you need the horizontal intercepts, in particular the positive one. If we were to go find this negative horizontal intercept, it would really mean it'd have a negative value here for that first coordinate, indicating a negative seconds, and that's not valid in terms of practicality. So we don't even find that one. So hopefully this helps you.